All right, so my topic is data warehousing trends, the best practices, and the future outlook. Quickly, a little bit about myself. I've been at Microsoft now for about 8 years. I had a brief stop at EY, but mostly working in the data platform and AI area of Microsoft in various different roles. I'm now in what's called Microsoft Consulting Services, where I help customers build solutions in Azure. And I've been at this a long time, and I speak a lot, particularly on this topic, about data architectures and data warehousing in there. And there tends to be a lot of confusion with a lot of these terms, and also just some getting started with why do I need a data warehouse, or what is a data lake in there? So we'll cover some of these topics. And if you look through the agenda, I'm going to talk about why you have a data warehouse, what is the difference between a data warehouse and a data mart. Kimball and Inmon, these are two different approaches to building out data warehouses that I'll talk through. I'll mention briefly the data vault. I'll talk about what a data lake is, and then I'll get into why do I see data warehouses fail and how to make them succeed, and then briefly cover some of the latest concepts around data warehousing architectures, which is the modern data warehouse, data fabric, the data lakehouse, and the data mesh. I always like to start out, and I've been, I would say, in data warehousing for about 20 years, and I've seen all sorts of data warehouses that people said were data warehouses when they really were not. One of them is I've seen customers actually take source data and copy it and put DW in front of this databases and say, oh, it's a data warehouse. Well, that's not what a data warehouse is. It's also not just taking all these source systems and unioning them together in some sort of view. That is not a data warehouse. And then it's also not an area where you can just land a bunch of tables and say, oh, we have a data warehouse now. You have to put a lot of thought into it. And that's one of the reasons why a lot of data warehousing solutions fail is they start out with a couple of tables, and then they, over time, get requests to add more and more data to it, and there's no design, and it becomes this giant mess. And so it's not a really good data warehouse if you don't think up front of and put a lot of design time into it. So you may ask, well, okay, why do I even want to have a data warehouse on there? The biggest reason is to have this central area that has all different types of subject. It could be HR and payroll data and manufacturing data and finance data on there, and have this single version of the truth. And it's what we call an OLAP solution, online analytical processing. And it's not OLTP, which means it's not a database that you can do a lot of upserts, insert, and deletes. If you have an application and it's, say, an order entry system, that's what I mean by OLTP. You have people entering a lot of data in their individual updates, inserts, and deletes, where data warehouse is collecting data from all those applications that do that and making it where you could write once and read many times. And so the reasons for a data warehouse, and there's a lot of them, and I'll just pick out a few, and this deck will be available for everyone to have. The biggest one is reduce stress on a production system. If you think of, I got this order entry system, and I have a bunch of users taking orders, and it could be hundreds of users. And at the same time that they're entering these orders, if I am now doing reporting against that database, it may collide and cause performance problems. I could be running queries that are just stressing out the data, the server that's being used, and the CPU could be maxing out. And people who are trying to enter the orders also start complaining because it takes forever to put those orders in. And so you want to avoid having reports, especially big reports that are going to take a long time to run on the same system as the OLTP applications in there. So if you copy it off into a data warehouse in there, you're reducing the stress because you're running reports separately. It's also a data warehouse, a great way to rename tables. If you look at a lot of these source systems, if you're using some SAP type of system, some ERP type of system, many times they could have table names and field names that are very cryptic, T116. Well, when you copy that data over into a data warehouse, you not only copy the data, you copy the metadata, the naming of the fields and the tables, and you can rename them to something that's much more easy to understand for the end users running reports. And you can also model that data much more effectively. So that's another big reason a data warehouse is very helpful, is it makes self-service BI more plentiful, because an end user can easily look at the data and do its own querying reports without having to go to IT and say, well, I don't understand what these tables mean. You also have that one version of the truth, as opposed to having all these source systems everywhere. And what I see happen a lot is customers get different answers to the same questions, even though they're using the same data. It's because the data is all in different systems. And so it can get very confusing on how to properly query that. If you create a data warehouse and you do it properly, everybody's going to get the same answer to that same question. And so if we look at another way to look at why you want to have a data warehouse, if I don't have this central source of data and that single source of the truth, I could be in, say, shipping, and I need to run a report to use data among finance and marketing and sales. And so I'm having to run these queries that are going against all these systems in there. And so now you have a bunch of divisions within your company going against a bunch of different databases. And you can see through the lines here, it gets very, very challenging. If I instead centralize all that data, copy it from all those different source systems into one single version of the truth, when I then go to query it, I'm going against that one source. So there's work that's being done to build that single version of the truth, but the end result is not having to have this mess of going across all these systems. And like I said, you can get some of the benefits of renaming the tables and fields as you move it into this data warehouse in there. So the bottom line is you're going to save a ton of time in building reports because all this work's done for you. And then you can also slice and dice the data in ways you weren't likely to be able to do before. If you look at some tools like a Power BI, and you can dig into the data, and you can do all these things that is very difficult to do if you're running some standard reports or Excel. You can do so much more in these powerful tools if you collect all this data and centralize it. With a lot of companies I talk to, I see where they are in stage-wise, and the idea is to move up in these stages and to get more value from your data, what we call as digital transformation. Most customers are in stage 2, where they're just now collecting all this data that's everywhere, and they're centralizing it, like I talked about. And this is great for historical trends, so I can look at this data and see patterns and take action on those. But where you want to get to is stage 3, is to predictive analytics, where I can now start building machine learning models and predicting things like customer churn or when a part's going to fail. So I can take proactive, I can do proactive things in order to prevent, for example, customer churn. Maybe I can predict that this customer is going to leave based on all the data I've collected, and then send them a coupon, and maybe that's going to help so that person doesn't leave in there. Or I can predict a part's going to fail, and I can go and repair and replace that part before it actually fails and cause a lot of downtime and things like that. So this is where I see a tidal wave coming in the future of customers diving into machine learning, because they'll be finishing this stage 2, and now they have all this data that they can build these machine learning models off of there and do all this predictive analytics. And then you get to stage 4, whereas you're building a solution that can consume data no matter what the size, the speed, or the type of data in there. And the idea is I can collect all this data and get better insights into my business and make better business decisions because I have collected all this data. Even things like Twitter data. When a number of years ago, a customer said they wanted to collect Twitter data, and I couldn't understand why. And they said, well, we can use that to figure out what people are saying about our companies and be proactive and take action of that. Or I can use Twitter data to analyze outbreaks in the country for people getting the flu, and I can then move merchandise into that area. All sorts of very interesting things. But to do that, you have to collect a lot of data, and it requires you building a solution that has the flexibility to incorporate data that's going to be streamed in real time. It could be tons of data. And each of these stages, it depends a lot on the company, but it could be maybe a year to get from stage 1 to stage 2, and then maybe 6 months to go into stage 3 on that. Again, a lot of it just depends on how much data you're collecting. I've seen people get a lot of value out of data within a couple of months, and I've seen people take a data warehouse, and it's almost a never-ending solution that they're building, and that maybe it takes 6 months before they're getting data in there and be able to query reports off there, and then they go on for years just building out stage 2 and stage 3 because they're constantly going, oh, I can think of new data to put in here now, and I can think of other ways I can make better business decisions if I incorporate additional data. So a little bit about a data warehouse and a data mart. And again, raise your hand if you have questions, and we'll have you come off mute. So a data warehouse, think of it as I'm collecting all my data, all the subject areas. It could be finance and marketing, sales, and I'm putting them in that centralized location of there. And it has the lowest grain of that data. So it could be order data, and I have all the individual order records in there. Now, from that data warehouse, I can pull out subsets of that data into a data mart. So it's usually broken out by a specific subject, like finance, marketing, or sales. And then it can also be aggregate of that data in there. So maybe I don't need the finest grain in there. So a lot of times customers do that because you may have a department that wants to use that data, but they don't need any of the rest of the data. So we create this data mart for them for performance reasons. They can enhance that data mart. They can do things to it without affecting the source, the main data warehouse in there. And so these are terms that get a little confusing, and even more confusing now with some of the new products coming out. But think of it as data warehouse, all the data marts, a subset, broken out by subject. And this will help as I talk about the next future slides. The Kimball and Inmon methodologies, it's been interesting. These are sort of two approaches, but over time they've sort of melded together. But over the years, there's been, and you can go look at message boards, a lot of people touting one methodology over another, and they've been a lot of infighting on which way is the best, is which way I created this slide. But I think you'll see at the end they can work very well together as long as you understand the basics of each one. So when we look at the main differences there is with Inmon, his approach is this relational database, this third normal form of looking at the data and laying it out in there. With Kimball is a dimensional model or star schema, and it's facts and dimensions. And I'll next slide we'll go more into this, but it's dimensional, Kimball, and relational for Inmon. So the relational model is that third normal form, is creating these relationships and denormalizing data on there. And you'll have many tables that'll need to be joined together. You can have history tables. You'll have keys for each of these tables. It's really good for end user access sort of indirectly. And you create this entity relationship model when you're dealing with the Inmon methodology, where the Kimball, he goes into these facts and dimensions, that star schema. There's less tables because they're denormalized, and now you can have duplicate data on there, but that is usually worth it for performance reasons. And storage nowadays is very cheap. Gone are the old days when you had to really worry about duplication of data because storage used to be expensive, especially in on-prem, and those days are long gone. It's easier for end users to query and create reports out of data that's in a star schema format. And you can do things like slowly changing dimensions, which is a way to track data as it changes over time, which prevents things like, well, if I run a report now and it gives me the sales totals of everybody in a certain state, and if I change the data and people move and I rerun that report, what happens is I will get new numbers for, say, the prior year when that person was say in Texas last year, and I show their total in Texas. And if they move and I change the record, and say they're now in New York, it's going to be inaccurate, those numbers, unless I track the changes. So I will create these slowly changing dimensions, which means I will say this person was in Texas for this year and then moved from this certain date to New York. And when I run the reports, then it'll use that to make sure the reports are accurate. So that's what's slowly changing dimensions, which is a very big, important part of data warehousing and keeping your data accurate. And you'll see the dimensional modeling is much easier for the end user to query data when it's in that format than when it's in the relational model, which is usually more for IT to access the data. So if we look at this, when we have models of tables in there, the relational model looks like the one on the left. So you may have many tables, and the dimensional model takes all that data and combines it into these fact tables and sales tables. So which one is easier to use? Obviously the one on the right, as opposed to, hey, if I'm an end user, I need to go to this person who really understands how to join all these tables together, and that person becomes the bottleneck. And so you want to avoid that. So you do extra work and create this dimensional model. And so an end user can do that self-service BI, so they can go and create reports because they don't need to understand how all this is joined together. All that is done for them. So that's why a lot of customers and a lot of solutions are built and they use that dimensional model. And another name for dimensional is star schema. If we summarize those two methodologies, the Kimball is going to have what he calls this logical data warehouse. It's a bottom-up approach in that he takes all the data marts and he creates a logical combination of those to create the data warehouse. So he doesn't have this enterprise data warehouse and then data marts. He has data marts, and he says if you combine all those data marts, I consider that a logical data warehouse on there. And he advocates much more user participation in building out the data, these data marts, where Inmon, not so much initially, and now he's more for that, but you'll see it's a little bit harder for end users to get involved when you have that third normal form. And Kimball also says you can decentralize the data marts, meaning they don't have to be in the same physical data store or the same server. They can be all separated out. And they could be designed to be optimized for reporting. And you have these things like conform dimensions. So I could have a table like a date table, and I don't have to go in every single data mart and create the date table, because I can create one conform dimension that'll work across all of these data sources on there. So it makes it a little easier. And you have essentially two tiers. And so that means, because you don't have that large enterprise data warehouse, and so that means less ETL and less data duplication. Where Inmon has this, what he calls the enterprise data model, and it's that one central single version of truth with all the data, and that's your enterprise data warehouse. It's more IT driven and not as much user participation on there. You have these, from that though, he creates these dependent data marts, which I'll show in a future slide on that. So that could be sort of the data mart concept that is within Inmon. It was within Kimball on there. And he has more layers to it, so there's more duplication of data. So that'll be a little more clear in the next few slides. So starting with Kimball, if you look at the model, is you take the data from these source systems, and I always say you want to have some staging area where you want to copy the data immediately to reduce the stress on the source systems on there. So you copy it maybe every day. You're moving data over, and ADF is your data factory into the staging area, and then from that staging area, you then use ADF or any ETL tool to create these star schemas, these data marts. So each data mart is a star schema, and combining multiple and having multiple data marts, you have a logical data warehouse. And that's what I mean by the previous slides in there. And then from those star schemas, which are essentially tables in a database, I can then create what is called cubes or tabular models, where I have those star schemas in individual details. So I may have every single order record in there, and then I can move it into this model where I aggregate the data. And so it's a higher level. And the reason for that, it can make it much more quicker to do reports off of that because you've aggregated the data. And therefore the end user, when they're doing reporting, it's not having to sum up all this data. For example, orders by month. If you go against the lowest grain and you have millions of records, that could take quite a long time. If I run some process at night that aggregates all that data and puts it in there by month, the end user then is really querying just one record to get that data out on there. So that's what we mean by creating these cubes and processing that. With the Inmon solution starts out the same. You copy data into staging area, but it's then copied into this enterprise data warehouse on there in the third normal form, the lowest grain. And then he says, if you need data marts, you can copy that data out into a data mart. And what's kind of changed is Inmon can now say those data has said a number of years ago, those data marts can be in star schemas and not just third normal form. So now we're starting to blend the two together, as you'll see in a future slide. And then from those data marts, you can do the same thing. I can create these cubes, so these tabular models, and make it much easier to end users to get that data because it's been aggregated. So you'll see the difference is that corporate information factory, he calls that enterprise data warehouse in the middle. Well, why do you want this enterprise data warehouse when Kimball says you don't really need that? Well, one is a single version of the truth in there, because if you have all these data marts, it could be hard to know where is the single source of truth in there, because sometimes these data marts will have copies of the data. The same data will be copied in order for them to build out the data mart, so it can get a little difficult. It makes it easier to build dimensions off of the data instead of having to go back to the original source on that. So you have this enterprise data warehouse that has all the data. So if I need to create dimensions and different types of dimensions in there, it's much easier to go after enterprise data warehouse and back to the source systems in there. It makes it easier for consistency on there because you have this single version of the truth. And you'll see in a future slide what I mean by that. And then there's less ETL, because if I have all these source systems and they're constantly updating all these individual data marts, I'm having to use a lot of ETL to keep all those data marts refreshed, which may have the same ETL going to the same data sources in there. If I instead have this central area, I'm having one ETL to upload this central area, and then have those reports and other data marts go off of that. So in the end, you'll have less ETL refreshes that have to be done. So it's one place to control the data. So think of data governance. I now can make sure everybody all the data in that enterprise data warehouse is being governed properly, as opposed to more difficult of trying to find all these data marts and putting governance on them. And I always say, well, you could skip having that enterprise data warehouse if I only have a couple sources and I'm having reports and I don't need a lot of reports, is maybe I don't start out with that enterprise data warehouse. However, you have to be aware of, people usually start out with a small number of data sources and it quickly grows, and then they could be overwhelmed. So which model to use? And in the end, they're not that different. They become pretty similar over the years, and they can actually complement each other. So there doesn't have to be this battle anymore. And it boils down to, Inmon has this normalized data warehouse before creating the dimensional data marts, and Kimball kind of skips that part. And so little tweaks, they look pretty much the same. And what you want to do is just understand both approaches, maybe do some more reading, and then see what fits for your particular use case. But no matter what methodology you pick, there's a lot more to having a successful data warehouse. Is a lot of it is soft skills, leadership, communication, and the planning and all that. And we'll talk a little bit later about why I've seen them fail, and so I'll cover this in more detail. So we generally see a hybrid model now with customers where they combine the two approaches in there. So they do create this normalized data warehouse, and then off of that, they create these individual star schemas in these data marts, and then from that, they create the cubes and then go to reporting layer. However, it's not cookie cutter. There's many areas you can skip. So like the last one in there is you can skip having the star schema in a data mart, and you can go right into this cube or tabular model in a product like Power BI that goes right against the data warehouse, and you don't bother with having a star schema within that data warehouse in there. You can even go right to the source system and create a star schema from that. Again, you want to reduce the stress on the system, so that's usually not a way to go, but it depends. It could be a small little reference table, and it could be fine to pull that off because it's only a few records on there. So this is the way people have gone. Now, everything in here is talking about relational databases in there. And which changed a lot is the concept of data lakes, which I'll get to in a minute. But even with data lakes, once you go from a data lake, which can replace that staging area, and you get into relational databases in there, you still want to go through this process of how we're going to lay it out in third normal form and star schemas. And I have to mention the Kimball methodology is more than just what I covered. His books go into, well, how to get business requirements, how to plan things, how to design dimensionals or star schemas on there, how to test and debug, and how to set up your teams on there. And there's this great book called the Data Warehouse Toolkit. I still consider the Bible. I have it sitting back there. And now it's dated in the technology being used, but the concepts still apply. And then he's got other books that are technology agnostic that still apply, where it goes into very deep details of how to do dimensional modeling. So you still can use those books to understand that piece of it on there. But it's a lot to do with project management, which is still relevant in there. It could be updated maybe a little bit when you get into agile methodologies and Scrum and things like that, but you'll still find it very valuable. And to quickly mention the data vault, this is a concept that has been developed over 20 years ago now. And think of it as a way to get additional auditing and historical tracking in the solution you're building on there. So it's more work. But if you say, look, I really need to track all aspects of the data, I need to track changes in the relationships, like I mentioned before, of customer changing from Texas to New York, but I need to do that on a grander scale. I also need to track the data where it's sourced from over time, because maybe I have sources changing and I need to be able to look at the history of that. If you get into that area, then you may want to look at the data vault as extra work, but it may be worth it in your use case in there. So this is a great link that you can go, it goes into more detail on that. And this could be a long topic in itself. I don't see this widely used, so it's kind of like the chicken and egg. If it's not widely used and people don't use it on there, well, I think it's got a lot of good use cases. Just be aware, if you build it, you may have a lot of, be more challenged at finding people who can maintain it and improve on it if it's not widely used concept. If we look at traditional approaches, we have this top-down approach, which is, I know the questions to ask. I'm going to do the upfront work to model all this out, and then I'm going to build my solution. Different approach compared to a bottoms up, where I don't really know the questions to ask. I need to just play around with the data. I don't want to spend a lot of upfront time with this data because I may not even find it's valuable on there. But if I do, I want to be able to model it later. This is the way we think of a bottom-ups approach. And in many cases, people use top-down for historical, looking at the data, and the bottom-up is really great for the predictive analytics. If I want to be a data scientist, it could be just dump the data in there. I'm going to start playing with it. I'll build some machine learning models off of that. And so these two approaches have combined. If we look at the top-down approach, this is traditional data warehouse. As I mentioned before, you gather the requirements, you build all these, the data warehouses, you build the tables and the fields, and you write the ETL, and you do all this work up front, which helps the end user because you've done in IT, you've done the work for them, and then they can then create reports off that. With a data lake, the bottom-up approach is, I'm going to take all this data, land it in this data lake, and it's a file folder format on there, so it's more challenging to pull data out of that. But for those power users or those data scientists, they can use this data right away because it's just like copying a data to a folder in your laptop. and right away I can start investigating that data. And it's particularly important if you're pulling data from Twitter data or IoT data from sensors and such, because a traditional data warehouse just can't handle that data in most cases in there. And so you need the data lake for that type of data. And if you find this data valuable in the data lake, then you can say, well, I'm gonna pass this on to an end user. I'll do that work to make it easier for them to consume, but at least I'm not wasted my time and giving them something and do all this work and they don't find any value out of it. And so this is where these two approaches, maybe for the last 10 years or so, have combined, having a data lake and having a data warehouse. A little bit more about a data lake and why you would use that. And I'll just point out a few of these. The biggest is freeing up the expense, the stress on a data warehouse. If I pull all this data from all these source systems into a data warehouse, usually what I have to do is I have a maintenance window. I kick everybody off. I load the data. That may take hours to load it and then clean it. And then hopefully it finishes on time. I can let the users back on and we're good to go. So the challenge right there is if you need a data warehouse that's 24/7, you can't do that. So you can think at the very least for a data lake, I can pull out that loading and cleaning of the data into a data lake, and then I can put separate compute on top of that and clean all that data, maybe aggregate it, and then make it, then load it into a data warehouse. So I have a very short window, maybe a few minutes, where there could be interruptions, as opposed to this maintenance window of many hours in there. So all this work is done outside of the data warehouse. And with the technologies today, you can get unlimited compute on top of that data. So if you want to spend more money and you need the data cleaned fast, you can do it against a data lake on there. So that's one big reason, is pulling out those staging and loading tables out of the data warehouse on there. It's also great for storing data that you may or may not find valuable. So let's just put the data in the data lake, because storage in there is extremely cheap. And I can go and check out that data later and see if it has value, where you can't really do that in a data warehouse because you're limited on space. The compute's expensive. If you start loading data that you may or may not need in there, it could be cause performance problems, and you could run out of space on that. And then finally, for a data lake, it's great for those power users to investigate the data, as I mentioned in there. And the tools have gotten much better now at allowing you to land data in a data lake and then quickly query it, even if you're not a power user anymore. So that's great for investigating if the data is useful. It's great for maybe I just need a one-time report and I don't want to have all this work done. But there's always that trade-off, is if I put it in a relational database, I'm doing the work IT up front to make it easier for the end user to consume. And if I don't do that, it may be a lot more difficult for end users. And so you always have to strike that balance. So if we look at it at a high level, if we have a data lake and a data warehouse, think of your data lake can be the staging and prep area for and the power users and data scientists can use it. It's great for data exploration, one-time reports. Don't know the questions to ask, you just want to explore the data. The data warehouse becomes your serving and security layer. So it could be a lot easier for end users, the business people, to go and query and report off that data. It could be helpful because the queries will run faster, because a lot of parts of a data warehouse where you can do tuning and statistics and query plans and all these things that you don't get in a data lake. In addition to security, if I need things like row level security, column level security, those things don't exist in the data lake. So it can be a lot easier to serve data with the security tools that data warehouses have had for years on that. And you can put more compliance on data in the data warehouse on there. So great to have both of these and just understand the features and the benefits you'll get from both of these particular stages. So why data warehouses fail? And Gartner says 70 to 80% of them fail. And that's, I think that's too high, that number, because their definition of fail is, what does that mean? But regardless, there's a lot of it who fail. I've seen executives who just think data warehouse is easy. I think they sometimes work with, we need it all done in 3 months, and then they work backwards. That's always very troublesome. They don't get the users involved early on, so users get reports and they may see problems and they complain right away because they haven't been involved in building it. So get them involved early. You work with them to to see the accuracy of the reports, ask them questions because they're the ones that are going to use it. And so get them involved so when it comes out, they're much more acceptable of problems that may appear. Not having enough business requirements or just overdoing it with business requirements, not spending enough time designing out the system, not planning for data governance, going in there thinking, oh, my data is going to be clean. And then you find out it's not, and you just need to spend all this time. And that's a big problem in most project plans is they think, oh, it won't take much to clean the data. And it usually takes a long time to get it accurate. And then choosing the wrong technology. And this is very challenging because there's so many options now. And that's why people like me exist at Microsoft to help customers choose the right technology based on their use case. So spend a lot of time up front, because if you go down the wrong path of the wrong technology and you need to go back again, that could be a reason why they fail. And why they succeed, choosing the right technology. Spend some time up front. Hire an expert if you need to go over all the options and make sure you're choosing the right one. Understanding those data warehouse architectures, what I went through, the Kimball Inmon, the star schema relationship, and some of the concepts that I'll talk about after this with the data fabric and data mesh and data lakehouse. Find a good champion sponsor on there, somebody who's part of the business who's going to root for you and remove blockers that may happen. Have somebody who call them a data warehouse director, and that person is making sure everything is running efficiently. So they're removing those blockers. They're making sure they have enough people in there. They're not making sure people are in endless meetings in there. I've been there. And if you have somebody who's running this real efficiently, it's going to make it a much more greater chance of success. Having an iterative or agile approach to it, maybe using Scrum, and you're breaking the project into phases or sprints on there. And then you pick out some high priority subject that you want to put into the data warehouse and find one that's high priority, but it's smaller and easier to do, and you get quick wins. So you create the data warehouse and you only have a subset of the data, but you've laid the groundwork, and then the end users can see something within a few months, if not a few weeks. And then you get them on board and then promoting it. And then you start adding more data sources in there. And so you don't have this big bang approach on there, but you rather have those quick wins. And then when you do that one small approach in there, you create this repeatable process and you learn from the mistakes and you improve on them. And so as you onboard more data sources, you have much more success. Get people excited through training on there. So what they may be using a new tool like a Power BI and they never used it before. And you get them in there and you train them and show you the power in Power BI, and they go, wow, this is awesome. I'm able to do things I never even imagined before. So now they're excited, and then they're telling everybody else. And that's building up the excitement is a great way to make sure your project is going to succeed. And then you can use a tool like Power BI or a Tableau to prototype. And instead of asking the end user what they want and them telling you, you can build a prototype in a product like Power BI very quickly and easily. And then they could be giving you their feedback based on that prototype you built. Or even the end user can build a prototype in Power BI because the tool's so easy to use. And so they're coming you, and if you ask requirements, they go, here it is, I built this BI prototype, just use that. All right. So getting into some of the data architectures. One of them is the modern data warehouse. And I usually whiteboard this with customers. That's why I have it in this way. And you can spend a whole day with somebody going through what this is, but it's broken out into 5 steps. I need to ingest the data. So I take all these source systems, and in this case, I'm using Azure products, Azure Data Factory. Any ETL tool I can take to pull it out of the source system and land it into this data lake. So storing it is the second way. And that storage is a data lake, and you have to design the data lake. And this is where you need to spend a lot of time up front. How am I going to design this data lake? Because usually you have a raw area, so the data comes across as is from the source system. Then you clean it, and that's where step 3 comes in, transform. I may use products like a Databricks or Azure Data Factory and clean that data, and I land it back in the data lake. I then may join that data, aggregate that data, and I create that presentation layer in the data lake. And I also may have a sandbox layer where I can copy the data and people can do what they want with it. And so you have these layers. Within those layers, you have folders. So you have to understand the way to break them out by folders. Maybe it's by subject matter and then broken down by date, or other ways for security reasons. So put a lot of time up front in going through data lake design. So you create your data lake, but as I kind of mentioned before, it's a file folder structure. So it may be too difficult for end users to query data off that. Although tools improved a lot, it still can be challenging. So in a lot of cases, you still want to model the data, and that's taking it from the data lake and putting it into a relational database. And I put it in third normal form. I may then put it in that star schema. So I'm making it much easier for the end user. So the work becomes worth it. The work required to do that extra ETL, extra cost, becomes worth it because I get to step 5 where end user can visualize the data very easily because that work's been done for them. And they can just go to a workspace and they can drag fields off of those tables and build out the reports without having to get IT involved. That's the modern data warehouse. When we look at the data fabric, and these are my definitions, I would say a large majority of people in the industry have similar, but they could be different. So don't take this as gospel, but rather, hey, this is James's opinion of this. And I think you'll see even ones that are different, they still have the same characteristics. So data fabric, think of it as a glorified modern data warehouse. And I'm adding extra features on top of what I just discussed. Maybe I'm adding real-time processing. I'm using virtualization software. I'm mastering the data. I'm creating these metadata catalogs with lineage so I can see a graph of how the data has been moved across all from the source systems into the data warehouse in there. I have more security on there, so I create these data access and these data policies on top of that. I may create APIs for accessing the data. I may build this out in building blocks. So I could give people those building blocks, maybe a data ingestion piece, even if they're not using a data fabric. I built this out with these building blocks to be reused outside of this data fabric. And so the data fabric, because it's a fabric, and meaning think of it as it's a solution that takes more work, but it can ingest data no matter what the size, the speed, or the type of it. And so that's why we call it data fabric. It's more glorified modern data warehouse because it can handle more data. And so most customers, when they're talking about building out data warehouses, they're now using the term data fabric. All right, hopefully people are able to use their hands because I haven't seen any. And sometimes you got to turn that on. So just be aware if you need to make that available when I get to the end for questions. The data lakehouse approach, we've gone over time to starting out. We had in the 80s, back in my day, a data warehouse, which was all relational. Products like Teradata and Netezza can handle millions of rows of data, even billions, and it was all done in the relational database, and it worked great. Then we came out in the late 2000s, maybe 12 years ago, with this data lake concept, which was a file folder format, and I can land data in there. And unfortunately, people thought it was this land of unicorns and rainbows, and I just put the data in there and it'll all come out magically. And that failed miserably. And people realized it's too complicated because they were getting rid of their relational databases just using a data lake, and that didn't work. So they came out with this cloud data platform approach, which was what I talked about before, combining a data lake and your relational database together. And that's been around for a while, will continue to be around for a while. But there are use cases that may be improved upon, and one is called the data lakehouse. And the idea is we go back to the data lake using just that. And you should be thinking, well, wait a minute, you just said that failed miserably. What's different about data lake today? And the idea with a data lake is you're combining a data lake and a data warehouse together in one. And the difference between now and in the late 2000s is a thing called the Delta Lake. This is think of it as a software layer on top of a data lake that gives the data lake additional features. If you're familiar with database terms, ACID transactions, it adds that to a data lake. It adds time travel, meaning I can version the data as it comes in. And that'll help me for rolling data back or auditing data because this additional software layer is tracking versions of the data as it comes in. It's a unified platform for both streaming and batch. And adding streaming is usually very difficult to adding to a data warehouse solution, but this Delta Lake makes that much easier. Schema enforcement means if I have data in files and they have to be in a certain format, and if I dump a file in there that's in a completely wrong format, it'll blow up and cause all my ETL jobs to fail. Delta Lake supports schema enforcement, so it will reject that file. So that goes a long way in preventing your ETL jobs from blowing up. And then the biggest reason is to support commands like delete, update, merge. Those commands don't exist in a data lake. And so in a Delta Lake, especially with many customers updating data in a data lake, it's much easier to do that with these commands that are built into the Delta Lake. And it also has a lot of performance improvements. So a lot of customers who are building out a data lake are using Delta Lake, and that allows them to, some cases, get away with not using a relational database. But there are a lot of concerns that I list here, and I won't go all of them, but at a high level, think of if I don't have a relational database, queries will be a lot slower going against a Delta Lake. So that may or may not be a problem. You just got to see what your end users are expecting. There's no row level security and column level security and other securities that you see in a relational database. They don't exist in a Delta Lake world. It's more challenging for customers and users to deal with data in a file folder format because the metadata could be embedded within the file or in a separate file somewhere that you don't even know, may not know exist. Where in a relational database, you're forced to go from a metadata to a data. So it has this great linkage of those two together. So it's much easier to go and peruse a data warehouse and see what's in there compared to a Delta Lake on there. And then there's some technology, you have to use Spark SQL instead of T-SQL, which you may be used to, and you may be used to a relational database. So you have to be aware of all these things. And you may go through a list and go, okay, that's fine, especially if you're using some of the newer tools in the Microsoft world, like Azure Synapse and Power BI, and they address things like the speed and the row level security on that. And so more and more customers are going towards the Delta Lake approach and bypassing the relational database. But I would say maybe 10% of customers are taking that approach. That'll increase over time, especially as Microsoft is coming up with new features that you hear about later in the year for a data lakehouse. But just be aware of these concerns. And you may think, well, I'll try it with a data lake and a Delta Lake until it doesn't work. And then maybe I find, oh, it's not fast enough, and then I go to relational database world in there. All right, last architecture, data mesh. Everything I talked about has been centralizing the data in one space. The data mesh takes a different approach of decentralizing it. And I have a whole talk that spent an hour just on a data mesh and go in more detail about how all these compares to a data lakehouse. But the idea is instead of centralizing it, we keep all the data separate into domains. And so what do I mean by that? So there's 4 principles of a data mesh. And the first one is domain ownership, is that I may have domains like manufacturing, sales, and supplier. And if they are copying the data into a central location, that means IT owns that data. Instead, let's keep it all separate, and those individual domains will maintain ownership of the data. So they will go to step 2. Principle 2 is they will own the data, which means they will need to clean it and aggregate it and make it and put it in the data lakes and data warehouses and make it available for others to use. They make it available through maybe API calls where people outside of the domain can query and find out what's in that domain. And then if they find something valuable, then they can query that data on there. So they're treating data as a product. They may have a contract that they have to follow all the domains. So there's consistency of how they're going to make that data available. And then they have the responsibility of having domain teams. So they have their own mini IT departments on there. So this allows you, as we'll talk about, to scale. And this is why data mesh is becoming popular is because the ability to now have teams, and as you have more data products, you have more teams on there. Instead of IT being the bottleneck, if I add more data, I could be further causing problems with IT. With the data as a product, as I add more domains, I build out the teams, and each of those teams are having their own infrastructure. And so I can scale out more domains, more people, more infrastructure. No more IT bottleneck. Now to do that is principle number 3 is I want to have a infrastructure as a platform. So I want to make it easy to build these domains. So in essence, maybe they click a button and the domain is the storage and the compute and the ETL and the security is all built out for them, and then they can go and do their work on top of that. Without that, and there's no products that currently exist that do that, you don't want each domain doing things on their own. You want to provide some upfront work or frameworks so they can not have to spend all the time and then you have every domain doing it their own way. And so that gets into principle 4, which is federated governance, meaning I want to have policies for all these domains. Since they're doing things on their own now, we can't have them defining, each of them domains defining what their own security is. So we have to have those policies in place and these rules in place. Okay, here's how you're going to secure your data. Here's how you're going to clean the data. We want consistent rules. Here's regulations you have to follow. And then here's the way you want to model the data. So we have that consistency among all those domains. So this is all the principles number 4. And so the challenge of data mesh is people don't understand all this and they have different opinions of this, and then they may build out the data mesh, but they're not following all 4 principles. So is it actually a data mesh if you follow 3 or just 2 of the principles? I don't know the answer to that, but this is where we have a lot of confusion of data mesh. So in the end, you go from this centralized world to decentralized, but not everything is decentralized. So principle 1 and 2 are decentralized in the ownership and the infrastructure. But if you look at step 3 and 4, those are centralized. I have to have a centralized team that's creating this model to build your domains off of. And I need a centralized team that is providing the governance over all of the domains. And so that's where a little confusion comes in there. And so this is data mesh is a very interesting concept. I would say it's something to be used by a very small percentage of users, but for those use cases, it could be very valuable. So that could be an avenue you want to take and do more investigation of data mesh or any of these other architectures to see what works best for you. All right. Oops. So that gets the question and answer. So I have 5 minutes about to answer here, and I'm happy to take questions if you send them to my email.
We have several questions. To summarize some of them, I would say that people are asking about the use cases. So we have the exact question about the top-down, bottom-up slides related to them. So what are the typical use cases for each of the approaches? And also a question regarding the how to apply this, if you had any experience applying these technologies to the legal services, if you had any use cases or some clients from the legal services. If you'd reply on that, it would be great.
Yeah, I can answer all those questions with that common term, it depends. So what I typically do with customers is discovery. I'm going to find out your use case, what type of data, what size of the data, how often does the data come in, what format it is in, what are your skill sets. I have a list of about 50 questions I go through because all that is going to help me to understand what's the best data architecture to use, and then what is the best products to use. So anything I went through here, you could do that on AWS or Google. It doesn't matter. You can swap all the technologies out because they're pretty much equivalent in their functionality on there. But there's no cookie coder approach. It's going to depend, and there are steps that could be skipped if you have small amounts of data, if you're not streaming it, and then there could be more expansion on there. If you have hundreds of data sources and they're streaming data on there, I could add a lot more complexity to it. And then it gets down to What is your skill set? I'm not going to recommend a certain product unless you have some skill set. And so that's going to vary, point me in different directions in there. Licensing, pricing, all those things come into play. So unfortunately, it's hard to answer that without getting those specifics. And I wish there was a flow chart you could just go down. I've tried creating them. It takes a long time, and by the time I create them, they're outdated because the technology changes so quick. And that's the biggest challenge is you need to know the technology that's out now, but then because these projects take a long time, you need to know what's coming out. So if you're working with Microsoft, you want to get with somebody at Microsoft like myself who can say, well, here's what's out now, and let me tell you what's coming. And then this way you can decide if that may change the data architecture approach because of what's going to be out in a week or a month or even 6 months. And as far as industries, Microsoft now is very focused on industry solutions. So you may want to look at legal or healthcare or manufacturing. There may be data warehouses that are already built, or at least a framework is built for your particular industry. They have even industry clouds now at Microsoft, which essentially is you're still using Azure, but they just put things in place for manufacturing, say, and we have pre-built warehouses and reporting for your specific industry on there. And so you want to investigate to see if there's shortcuts and to building your solution because Microsoft may have already built out stuff that's common to your industry.
Thank you for the answer. Unfortunately, we're short on time. So all the attendees can send their questions to your email. I'm sharing it to the chat so people can copy that and send you this question, okay?
Yeah, feel free to send me the questions. I've deeper dive in my blog, but I'm very happy to answer questions, and we may even get on the phone and talk through your particular use case, and I can guide you in the right direction.
Yeah, and visit the James Serra's blog. I have shared the link in the chat, so you can get a lot of information there. Go through it. You have also the link for his book there, and I'm sure you will find a lot of useful information there.
Yeah, well, thanks everyone for attending.
Thank you a lot, James. It's been a pleasure, and we're moving forward.